Introduction to ICT and Mechatronics Training. Mechatronics is the application of electronics and computer technology to control the motions of mechanical systems. A mechatronics device is indeed composed of mechanical parts, electrical devices, electronic components, sensors, hardware, and it's operated and controlled under the supervision and commands that are programmed through switchable software. A typical mechatronic system picks up signals from the environment, processes them to generate output signals, transforming them from, for example, into forces, motions, and actions. The fact that such a system picks up changes in its environment by sensors and reacts to their signals using the appropriate information processing makes it different from conventional machines. Examples of products that have been designed using mechatronics engineering includes printers, robots, DVDs, car anti-lock braking systems used in our kitchens like the warmer, appliances that we find like the washing machine that we use at home, aircraft cameras, computer power stations, even in our toilet systems. Computer systems have drives and their drivers, both of which forms the key component of mechatronics. A drive is made up of electrical and mechanical parts designed to carry out specific functions, while a driver is a software with a set of instructions written to enable it to carry out specific tasks. For example, a printer is a mechatronics device because it has the drives, the mechanical and electronic components that works together with the drivers, which are softwares to enable it to function well. So to print, you will normally have to switch on your printer, and you also have to give instruction to the printer like specifying the document to print, the number of pages, and what color. So what happens is that when this instruction is given, the printer driver interprets these commands and directs the operating system to carry out the instruction. The hard drive, an example of mechatronics device. So the hard drive is made up of the components as shown there, and all this works together to store digital data. So notable among these is the actuator, the read-write head, and of course we have the spindle and the disk. So let's see how this works together to store our documents. The mechatronics part of hard drive includes the servo mechanism that controls the position of read-write heads of the hard disk drive, and the spindle motor system that spins the disk at precisely regulated speed. The key components of hard disk drives are the platters for storing data, the spindle for spinning the platters, the read-write arm for reading and writing data, and the actuator for controlling the actions of the read-write arm. So how does this component work together to enable us to store a digital document? Now, the hard disk drive contains what is called a spinning platter with a thin magnetic coating. A head moves over the platter, writing zeros and ones in tiny areas of magnetic north or south on the platter. To read the data back, the head goes to the same spot, notices the north and south spots flying by, and so deduces the stored 0 and 1. A modern hard drive can store well over trillion 0/1 bits per platter, so the individual north and south spots are quite small. Flash storage is made up of chips, no moving parts, and is gradually replacing the spinning hard drives. Flash chips are what is inside the camera SDHC, that is the secure digital high capacity cards, and of course the USB storage keys. So let's look at the fault detection and diagnosis in mechatronics system. A mechatronics system typically includes sensors, data acquisition, actuators that operate in synergy, driven by specific control algorithm to perform a desired function on the control device. This section presents the diagnostics of mechatronic system using what we call the car diagnostic tool. So in this case, we're looking at the car, and we're looking at how we can diagnose fault in car using the car diagnostic tools. Before we look at how to diagnose fault in car, it's important that we understand how the car engine works. So the first thing we look at is the combustion in cars. A gasoline car typically uses a spark-ignited internal combustion engine. In a spark-ignited system, the fuel is injected into the combustion chamber and combined with air. The air fuel mixture is ignited by a spark from the spark plug. This results in the burning of gasoline. The resultant heat energy from the burning of gasoline is converted into mechanical work that is applied to the wheels to make the car move. So let's look at some of the parts of the car. The first one is the ECM. ECM means engine control module. The ECM, also called the power steering control module or PCM, is the brain of the engine management system. It controls the fuel mixture, ignition timing, variable cam timing, and emission control. It constantly monitors emission performance via its onboard diagnostics. The second one is the piston. The piston helps in the transformation of heat energy into mechanical and vice versa. It moves upward and downwards inside the cylinder in order to expand and contract a fuel mixture. For this reason, a piston is inevitable in an internal combustion engine. The air intake. The air filter prevents any insects, dust, particles, sand, or debris reaching the engine and ensures a good mixture of air and fuel to support performance. And then, of course, we talk about the fuel. The fuel pump carries gas from the tank to a fuel filter and also to the engine, where fuel injectors emit precisely timed spray of gas into the intake port. Then we talk about the cooling system. Engine gets very hot during operation and it requires cooling system. So the cooling channels around the cylinder and through the cylinder head carries a special liquid called antifreeze to keep temperature with safe operating range. It is called antifreeze because it will not freeze in icy water. After cooling hot engine parts, cooling circulates in the radiator. The water pump keeps the cooling system flowing and properly pressurized. We have the electrical section. The spark plug delivers the electrical spark that ignites the fuel air mixture for combustion. A gasoline car typically uses spark ignited internal combustion engine. In a spark ignited system, the fuel is injected into the combustion chamber and combined with air. The air and fuel mixture is ignited by a spark from the spark plug. Specifically, an internal combustion engine is a heat engine in that it converts energy from the heat of burning gasoline into mechanical work that is applied to the wheels to make the car move. Development of control system for mechatronics using artificial intelligence. Artificial intelligence is the science of making machines smart, can contribute to the development of software and hardware in mechatronics. And here we're going to demonstrate how this works. How to demonstrate the concept of artificial intelligence. And in this example, I will need to go through the following step. I will need to install what node, install Visual Studio Code. Then I will open to the terminal. I will add the brainjs.example-master, and I will click to load the first project, which has this combination they are seeing here. So you can see that this application requires what we call the brain.js. So I want you to look at brain.js as the central controlling unit, the brain, that has been computed to analyze the data that you give to it in order to give you the solution that you're looking for. So in this example, I'm going to feed it with this combination. So I'm feeding with this combination, and then I'll now tell it to predict what happens when the condition appears this way. So here, when it is 0, 0, 1, the result is 0, 0, 0, 1, 0, 0. So when you have 1, 0, 1, you have 1. Then when you have 1, 1, 1, you have 1. So what will happen when it is 1, 0, 0? That's what we want to do. So to get this done, I have a folder on my desktop which is called artificial intelligence software. Then I have my brain.js, which is what I'm going to have the Visual Code and the Node software. This is what will enable us to work. So I already have Visual Studio installed on my system. So I'll go to File, click on Open Folder. Then I'll go straight to Desktop, open to Artificial Intelligence. Then I'll load this. I'll click on this and say open it. So I'll wait for it to load. So you can see from here the entire folder loaded. Then I'll go to terminal and say run terminal. I'll wait for that to load. Then the computation that I've just developed is in 01 basic, so I'll double click on it. So when I double click, you can see the combination here. So this is what I've trained the brain. So this is the brain. So I require brain.js, a JavaScript. So that's the computing environment, central processing unit, if you like, the brain that analyzes the data. Then I feed it with this data. Then I'm telling it to predict what will happen here. So how do I run this? So I'll just come here and type node, N-O-D-E, node. Then I'll give the name 01 underscore basics. And press enter. So you see the system has predicted here and it's telling me that your answer is most probably 0.2, which is 0. So it's telling me here that for a combination of 1, 0, 0, your possible answer will be 0. So I'll just repeat that again to see what I will be given, and the same thing appears. That's how artificial intelligence works. So you can train the machine on data, and you would now tell it to predict what will possibly happen when a new set of condition changes. Thank you.